Thank you. All right, thank you. Good afternoon. So, among the excitement around the accelerated development and the increased accessibility of artificial intelligence has really been this sense of optimism in our industry for how AI can transform manufacturing and supply chain operations. But I'm commonly asked, as the industry just grapples with delivering on that transformation, what would be a clear framework for how we balance modernization with short-term financial ROI while still building the foundations for long-term innovative capabilities? My name is Joe Rosing. I lead our Center of Excellence for Manufacturing and Supply Chain at AWS. And in today's session, we're really going to talk about the best practice approaches for how we can modernize manufacturing and supply chain operations to really accelerate the benefit that we can be achieving with artificial intelligence. Now, that optimism that I spoke on before is really grounded in the sense that the industry right now is ripe for change and ripe for re-industrialization. And a lot of that is because of some unique challenges that our industry continues to face. We're still, for example, continuously trying to build supply chain resiliency. We're managing the impact of an aging workforce and demographics on business continuity. And we're also, struggling with risks or mitigating risks related to geopolitics and trade. But fundamentally, re-industrialization really has to be AI-driven. Because for us to build a competitive advantage through manufacturing and supply chain operations, it's all going to come down to how quickly we can perceive, react, and re-optimize based on these changing conditions. And we're going to have to do that at a scale and speed that simply surpasses human capabilities. And so the winners in re-industrialization are not going to be those that just implement technology for technology's sake or chase the latest models that got released. The winners are going to be those that really focus on where we're going to deliver a financial ROI, but also where we can deliver on the durable needs of the operation or of the supply chain. And I put those durable needs into three buckets. The first of which is reducing variation. So how do we become predictably boring at the key performance indicators that matter most for our business? But when it comes to AI, it's really thinking about that through the lens of how do we solve problems with human-like reasoning, but with machine-scale consistency. The second durable need really comes down to empowering employees. And we've been talking about empowering employees in our industry for decades. It's lean manufacturing, Toyota production system, common topics. But it's never more important than now when we talk about artificial intelligence. Because fundamentally, the role of artificial intelligence should be how we empower employees to make better decisions faster, and also how we use the technology to reduce the cognitive load on our employees and really free them up to do higher order tasks. And then the third durable need is just how we execute at speed and are able to re-optimize capacity against those changing conditions. And like I mentioned before, be able to do that at a scale and speed that's going to surpass the way that we can do it today through manual processes. Now, many manufacturers have started this journey, right? Like I said, there is a lot of interest, there's a lot of optimism around the role that AI can play in helping us achieve things like closed-loop manufacturing systems, helping us make real-time production adjustments or software-defined manufacturing, and further reduce variation in our processes. But the fact of the matter is, only about a third of the industry has their data in a place that they really can innovate at scale, and where they can quickly implement a POC, for example, of an AI use case in one factory, and then replicate that success across multiple factories. And so really the role that AWS is playing is helping us transition from our traditional model of how we manage data in the factories and the operations to one that is going to be really defined for us to achieve software-defined manufacturing. So if we think about this traditional ISO 95 Purdue pyramid model, it fundamentally is not built to support the demands and the requirements of an AI world. We have inherent data silos across each of those layers, and there's a lot of variation across each of those layers when we look at the global manufacturing footprint. And so a lot of the work we're doing from a modernization perspective, in the OT world in particular, is thinking around how do we get to this desired future state where we're running a lot of the IT applications in the cloud, but we're thinking about new characteristics of what the factory looks like. And we can define those characteristics by first saying, we're going to truly merge IT and OT and make sure that it's integrated, both as a function in terms of capabilities of our teams, but also from a technology perspective. The second tenet is really making sure that we can enable any-to-any communication. So for example, when we think about agentic workflows and how they might operate on the plant floor, or if we want to do closed loop feedback controls, it's going to require us to take an insight that we might be generating off of an IT system and drive the action or automate that action back into the hardware or the shop floor layer. And that's going to really, again, require this any-to-any communication capability. And then the third piece is moving beyond what we've traditionally thought of as systems of record and maybe systems of transaction to also now thinking about systems of action. So a control tower type of view or a way that we can observe what the AI is doing and how it's interacting with all of these systems. And that will also then fundamentally change the role that those systems of record and systems of transaction, so the ERPs, the MES, the SCADA systems, for example, the role that those systems are going to play in the operation. Now, as we do this, again, as I mentioned earlier, I oftentimes get asked for what are some of the best practice approaches, or how do we boil this down so we can think comprehensively about a long-term manufacturing strategy that allows us to drive modernization, but also get our data in a place that we have the right foundations for long-term innovation, and then start thinking about where we implement AI in our processes. So really, we think about this in 3 layers. The top layer we call digitally composed outcomes. So it's thinking about how do we achieve those common KPIs, improving maintenance reliability, improving quality yields, improving on-time delivery in full, for example. How can we improve those KPIs through technology? But what's different now from maybe a couple years ago when we think of the Industry 4.0 type of movement is we're not just talking about those topics in the sense of doing computer vision for defect detection or doing predictive maintenance. Instead, we want to think holistically about the process. How do I redefine the way we do maintenance management? How do I redefine the way we do quality management? Because now we have new tools at our disposal to create future state process maps that are way different than the traditional way of doing these things. So we're going to have a look in a minute here of how we can integrate AI into redefining those workflows. The second layer we call our industrial data fabric. And this is really where we talk about industrial data ops and driving contextualization of that OT data as close to the source as possible, and building the knowledge graph that really becomes required for us to have this data foundation where we can innovate off of that at scale. And it's building common patterns such that when we have success in one facility, this is the layer that allows us to extend that success or replicate it across multiple facilities. And then the last layer is thinking about manufacturing application modernization, and doing that also in mind of what is the role of OT security, or how do we maintain OT security as we go do this modernization and actually achieve a higher security posture than we might have today. And so this is where we're commonly working with customers now about looking at those traditional applications like a SCADA, a historian, an MES system, and how do we deploy those on a modern hybrid-based architecture where we're still meeting the latency and the security requirements at the edge, but we're achieving the cost efficiency and the DevOps capabilities of the cloud. And so one way to kind of then take this one step further is just to further simplify it of those 3 layers. The top layer, we want to talk about creating a common user interface for integrated workflows. The reason this becomes important is because today, a lot of operators are interacting with multiple systems. Think about the time it takes for an operator to come up to speed on their job if they have to interact with an MES, an EAM, a CMS, an ERP, all these different applications on the shop floor. But now with the ability of implementing AI into these workflows, we can actually create a common layer, a common user interface that greatly simplifies how we execute operations, and it removes some of that cognitive load off of our employees. The second layer, when we talk that industrial data fabric, really what we want to achieve here is building new business capabilities and data products that allow us to, once we have that data product, have repeatability up the stack in terms of the analytics or the models that we build off of that data. And then on the bottom layer, when we talk modernize, it's really developing a repeatable process around how we assess requirements of those applications, how we mobilize the teams around capability gaps that we might have in today's environment, and then modernize the application on a hybrid architecture to address those capability gaps. And we might do that application by application, but it allows us to develop a repeatable process where we can accelerate that whole transition and really build out a long-term roadmap for modernizing those applications across our global manufacturing footprint. Now, I want to dive a little bit deeper into building that common user interface for integrated workflows. Because what's different now, as I mentioned before, is our ability to pull new tools out of the toolbox to redefine how we do work and how work gets done on the shop floor. And as you read the quote, what's important to think about is not just plugging AI into the existing workflow. That's just a short-term view of how we might get a POC done, but really doesn't help us build lasting change and build lasting competitive advantage through the way we execute manufacturing and supply chain operations. So what we want to do instead is take kind of a traditional approach of systems engineering, but look at the new AI tools and think about this in a way of AI systems engineering. And we don't want to look at these tools of automation and assistants or chatbots and agents as a progression, right? This is not something where we start at automation and we've set a goal that we're going to have every workflow be fully autonomous multi-agentic systems. These are in fact different tools in the toolbox that we're going to pull out and use most cost efficiently at the task level for us to have an overall systems engineering approach for how we are going to re-architect the workflows or the processes on the shop floor. As we go about doing that, there's a couple tenets that we want to keep in mind. The first is we simply don't want to automate the existing process. There was a senior operations leader I was speaking with about a month ago who said, look, the reason why we're looking at this process is it's broken today and it's chaotic. And the worst thing I could do right now is automate chaos. So what we really want to do is let's map out the current state workflow or the current state process, but we want to start with a blank sheet of paper and build that desired future state process map, and then think through there what is the right tool. And that brings us to the second point, which is no tool rules them all. So as much as we've been talking about agentic AI this week, agents are not the hammer for every nail, okay? They are not going to be the most cost-efficient way to do every application. It's also going to be that we don't necessarily need to get to lights out and fully autonomous on every task. But again, we're going to think very strategically about what's the right tool for the job. And then lastly, we want to establish a new baseline for continuous improvement. So when I meet with customers, many have a very strong culture of continuous improvement, and they've done great work through Kaizen events, and we don't want to lose that. But we still want to make a leapfrog jump in our capabilities and create a new baseline from which we can drive continuous improvement off of. And so that's really kind of this starting point now, or this checkpoint that we have of redefining workflows with this AI systems engineering approach. And we think about the framework now of, okay, well, what tool do I use when? We can map that out against a 2x2 matrix of complexity and risk. So when I build out my desired future state workflow, I'm going to identify all of the tasks in that workflow. And then I might say, okay, for given tasks that are lower risk and lower complexity, those are ones that it's going to be most cost efficient for us to automate. These are typically deterministic workflows. They're rules-based. We can write if-then statements. Again, the most cost-efficient way is going to be automating those tasks. The second box we might look at are tasks that are going to continue to be done by the human. So a simple example of this might be actually doing the maintenance on the machine. A human is still going to have to turn the wrench, if you will, on the machine, because an agent won't be able to do that. But I want to accomplish that task at lower variation, and I want to empower the employee to accomplish that task at a high performance or according to best practice principles. And so this is where I'm not necessarily going to have a chatbot, but I'm going to mature that chatbot into a formal AI assistant. And what I want that AI assistant to do is provide troubleshooting guidance so I can perform that task at lower variation and, again, at best practice performance. And then the role that agents come in is really twofold. So where I have a lower risk profile on the task is where I'm going to delegate that task to the agent. I've achieved a high enough confidence interval in the output of the model or the output of what the agent is going to go do, that I'm just going to delegate the agent to go do that task, because it now removes it as something that I need to have a human do, and it reduces that cognitive load on the employee. If it's a higher risk profile task, I'm going to still probably do it through an agent or a predictive model, but I'm going to put a human in the loop. And that's okay. Again, we don't need to bring everything to be a fully autonomous system. But if it's higher risk, we want a human in the loop to check the recommendation that's being made by the predictive model, or check what the agent wants to go do before we give it the green light to go do that activity, right? So this is just a simple framework that helps us to think about, again, we have these new tools in our toolbox. How do we do this AI systems engineering where we pick the right tool for the job based on the risk profile of the task or the complexity of the task, such that now we have a redefined workflow that appropriately integrates AI into the way we get work done. Now, the last slide that I would end with is just a little bit of a challenge, that the speed at which we can accomplish this transformation really comes down to a leadership decision. So the speed at which we can encourage our teams to drive continuous improvement through AI systems engineering, the speed at which we can build competitive advantage through integrating technology into our manufacturing and supply chain processes, the speed at which we can further use technology to reduce variation, empower employees, and re-optimize our operations, comes down to a leadership decision. And comes down to a decision of really driving our teams to dive in and start transforming. And that's really my last point of encouragement, is the best place to start is to just get started. Let's pick a workflow that we can really dive into that's begging for improvement. Let's identify the KPI that we want to improve as a result of that workflow, and really work backwards into what's the data requirement to improve that KPI. And then from there, we can look at, okay, what is the data strategy and the modernization plan that we want to build so that we can comprehensively go improve that workflow across your manufacturing footprint. And so with that, I want to thank you for your time today. If you have any questions, I'll be off to the side after this session here. But thank you for joining us at reInvent, and I hope you have a great rest of the afternoon.